Let's talk about how we can refine crude metals, that is metals with some impurities, to get pure metals out of it. And for this, there are many processes. But in this video, we will be taking the help of electricity. We'll be talking about electrolytic refining. See, so far we have been talking about extraction of pure metals from metal ores. And we spoke about what are the steps over here. The first step was enrichment of ores, where basically we crush the ore and we separate the metal compound out of the impurities. Now the second step was conversion to metal oxide. See, if this metal compound is a sulfide or a carbonate, first thing we do is to convert it to metal oxide. And the reason for doing this was because it's easier to extract the metal out from the metal oxide. And that's our third step. We reduce the metal oxide to get the metal out. But see, this metal is still crude. It still has some chemicals that we don't want, some impurities that we don't want. And we need to get rid of that because pure metals are used in many industries, in many delicate work. And if there are even a small amount of impurities, everything can go bad. Your mobile phones, your laptops, they all use pure metals. And if there are impurities, their properties will change, right? So that's why we need 99.99% pure metal. And that's why we are going to refine them. So let's try to understand electrolytic refining with the help of an example. So let's say we started with copper metal. So we had copper ore, and in the first step, we enriched it, meaning we separated the copper compound from the impurities. And in the second step, we converted the copper compound to its oxide form. And in the third step, we reduced it to get the copper metal. Now this is still in crude form, meaning it has copper and some impurities, some unwanted chemicals. So let's see how we will electrolytically refine it. So first of all, this crude metal, this is taken and connected to the positive terminal of a battery. Okay. Now the second step is we take a pure version from outside somewhere. We buy the pure version of the same metal. Over here, since it's copper, so I'll buy a wire or a strip of pure copper and I'll connect it to the negative terminal of the battery. Now these are going to be my electrodes. Now I'm going to dip these electrodes in the solution of the salt of same metal. For example, here the metal is copper. So I'm going to take the solution of copper salt. Here I'm taking copper sulfate. Okay. Do not take any other metal salt. Only take the same metal salt that is being refined. So just to recap, we took the crude metal and we connected that to the positive terminal of the battery. From outside somewhere, we bought pure metal that is being refined, which was copper, and we connected that to the negative terminal of the battery. Now these two electrodes were dipped in a solution of the salt of same metal that is being refined, here copper sulfate. Okay. Now the main idea is when I pass electricity, the copper atoms from the crude metal, they will come into the solution, and the copper atoms from the solution, they will get onto this pure metal. Okay. So as time passes by, this pure metal strip, this will become thicker and thicker. Copper atoms will keep on depositing on it. And this strip of crude metal, this will become thinner and thinner. The impurities from this, they will drop into the solution. Either they will dissolve in the solution or they will settle down at the bottom. And this is how we'll be able to refine it. This is how we will be able to get 99.99% pure copper. All the copper atoms from here will come and settle over here. Now let's look at the refining process a little bit in detail. So first step was to take crude copper, which is copper plus impurities, and connect it to the positive terminal of the battery. That means this is going to be our anode. This becomes our anode, the crude metal. And the pure copper, from outside we bought pure copper and we connected it to the negative terminal of the battery. That means pure metal is used at the cathode. Now we took the solution of the same metal's salt, which here in this case was copper sulfate. Copper sulfate, CuSO4. Now to this, we add a little bit of acid. We take acidified copper sulfate solution. And the reason for doing this is because by adding acid, we can increase the conductivity of this solution. The ions will be able to flow easily and faster. Okay. Now see what happens when we pass electricity. The copper atoms that are there in this crude anode, copper in this, it will lose 2 electrons and become copper plus 2 ion. Those 2 electrons, they will travel towards the positive side of the battery. Positive, negative, they attract, right? So the reaction that happens at anode is copper, it loses 2 electrons and becomes copper ion, copper plus 2 ion. 2 electrons are given off and this travels towards the positive side of the battery. So this happens at anode. Now see, this copper ion, this will drop into this solution. Okay. Now next is, since 2 electrons went up, then 2 electrons will come down. Equal number of electrons move in a circuit. Okay. So here 2 electrons are going to come at the cathode and this will attract a copper ion from the solution. So the copper ion, it will get attracted towards the cathode. It will take the 2 electrons from the cathode and will become copper atom. And this copper atom will stick to the cathode. And that's how pure copper atoms get transferred from the impure anode and get deposited at the cathode. So the reaction that happens at cathode is copper plus 2 copper ions, they take 2 electrons and then they convert to pure copper atom. And these atoms get deposited over here. So in time, all the copper atoms from the anode, they will jump into the solution as copper ions. And these ions will get converted to copper atoms and they will stick to this pure cathode. And the impurities that were present over here in the anode, they will either dissolve in this solution or if they are insoluble, they will settle down at the bottom of the anode. And this is called as anode mud. So after a while, you will see that anode is becoming thinner and thinner, and it might even disappear after a while. Whereas our cathode, this will become thicker and thicker with pure copper. So this is how we refine metals to get 99.99% pure metal. And since in this process, we are using electricity, this process is called electrolytic refining. Okay, with this, I have few questions. And if you are able to answer those questions, then your understanding of this concept is perfect. So let's try. My first question is, if I make the cathode of another element and not of the element that is getting refined. See over here, I made the cathode of pure copper, right? But what if instead I made it of carbon? What would happen in that particular case? Pause the video and think about this yourself. Now see, if I made the cathode of carbon and not of the metal that is getting refined, then in that case, copper ions will come still in the solution and then they will take electrons from the cathode and become copper atoms and will stick to the carbon. So here finally, we will see something like this. The copper, pure copper, is getting stuck to carbon. And later on, we will have to scrape off this pure copper from this whole carbon, right? So that's going to be another added step. And that's why we use pure metal as the cathode. Now, next question is, what if I use some other metal salt as the solution? See, we have been told that the metal that you're refining, use the salt of same metal as the solution. So over here, we are refining copper and we are using the salt of copper. But what if I use iron sulfate instead? What would happen? Pause the video and think about this. So see, if you pass electricity in this case, first of all, copper ions will definitely come into the solution from anode. But iron sulfate, this will also dissociate now and we will get Fe plus 2 ions from it. So in this solution, we now have Fe plus 2 ions and copper plus 2 ions. And it might happen that both of these ions get deposited over here on the cathode. So finally, the scene might look something like this. We have copper and iron also on the cathode. So see, this is still impure, right? We do not have 100% pure copper. So this also beats the purpose. Now one last question. What if we switch the electrodes? Meaning this time we connect the pure metal to the positive terminal of battery and the crude metal to the negative terminal. What will happen in this case? Pause the video and think about it. And if you have thought about it, let's see. So see, the positive terminal of the battery, it will suck electrons. Does not matter what is connected to it. Whether it's pure copper or crude copper, it will take away electrons. So what's going to happen in this case is the copper atoms in the pure metal strip, they will lose electrons and become ions. They will come in the solution and then they will take the electrons from this side, from the cathode, from the crude metal and deposit on top of the crude metal. So finally, after some time, the pure metal will start becoming thin and they will start depositing on top of the crude metal like this. So see, at the center of this, we still have many impurities, right? Even though the pure metal is on top of it, this is not pure. So this still beats the purpose. And that's why we connect the impure, the crude metal to the positive side and the pure metal to the negative side. I hope with these questions you understand the reasons why we do things in electrolytic refining. Now let's summarize the video. So far we saw that to extract pure metals from their ores, we first enrich the ores, meaning we separate the metal compounds from the impurities. Then in the second step, we convert the metal compounds to metal oxides. And in the third step, we reduce these metal oxide to get the metal, the crude metal. And in the fourth step, we refine these metals to get pure metals. And in this video, we saw one of the ways of doing it, electrolytic refining. Over here, we attach the crude metal to the positive terminal of the battery. And from outside, we buy the pure form of the same metal and we attach that to the negative terminal of the battery. We dip both of these electrodes in a solution of the salt of the same metal. After passing electricity, the metal atoms from the anode, they will lose electron and become metal ions and they will come in the solution. Now these metal ions, they will receive electrons from the cathode and will become neutral atoms and stick to the cathode. Now this is how the metal atoms from the anode side come to the cathode side. And whatever impurities are there at the anode, they will either dissolve in the solution or whatever is insoluble, they will settle down at the bottom of the anode.